Howdy guys, this tutorial is going to show you how to solve a system of equations from the elimination method. So the other day we talked about how to solve it from graphing. So I have this graph over here on the left side, and you can see that there's one solution to this graph, and the solution is right here where they cross. Okay, so right there where they cross. Sorry, my system's a little delayed. Okay, so where they cross, that is the solution, and it's given to us like an ordered pair. So an x comma y value. But what's making this a little difficult is these two lines do not cross on the grid. They cross like in the middle. So how do I know just by looking at that what the numbers are, what the ordered pair is? So I can see that that line right there is 5. So they cross somewhere between 5 and 6. And then down here, this is a negative 1. So they cross where x is about 5 and y is in between 0 and negative 1. But that's not good enough. In math, we want exact numbers. So the graphing method is great if, number one, you have graph paper, and number two, they're going to cross each other on a grid line. But what do we do when they cross each other not on a grid line, like in this example here? We would take the two equations and we could use what is called the elimination method. Okay, so we could also use something called the substitution method that you will learn, but we're going to focus on the elimination method today. Okay, so here are my two equations, 2x plus 3y equals 15, and then x minus 3y equals 3. So the elimination method, I'm trying to find out what the x value is and what the y value is. So in the end, I can come up here and I can make the ordered pair, the x value and the y value, where these two equations cross each other. That's what my end result is, trying to find that ordered pair where they cross. Okay. So the elimination method, we need to solve these two equations, but we cannot solve an equation with two variables. And here I see that there is the variable x. Okay. And I see that there's the variable y. And that's in both equations. There's an x in this equation and a y in the second equation as well. So I need to get rid of one of those variables in order to solve for both. Okay, so we're going to keep it nice and simple for today. So when I'm looking at this, I see a 2x and an x, okay? But I see a 3y and a minus 3y. And I happen to know that those are going to cancel out, because if I have 3 of something and I subtract 3, I'm going to end up with 0. So here I have positive 3y's, so I have 3y's, and I'm subtracting 3y's. So I know that those are going to cancel out, okay? So I am going to add these equations together. Okay, I'm going to add them together, and the first thing I'm going to do is I'm going to eliminate the y because they cancel each other out. So 3y and negative or minus 3y cancel each other out. Okay, you will later learn what if they don't, but you still want to use the elimination. You're going to learn how to actually make them cancel out. But for today, they're all going to cancel out automatically. Okay, so now let's just add what we have left. So we have a 2x plus an x. Remember, when you have an x by itself, there's a 1 in front of it. So 2x plus 1x is 3x. Okay, then I canceled out the 3y and the minus 3y. So now I'm going to add on the right side. So I added on the left, now I'm adding on the right. 15 plus 3 is 18. Okay, so now I need the x to be by itself, and it has a coefficient of a 3. So the 3 and the x are being multiplied, And we know in math to get rid of something, we do the opposite. We need them to cancel out. So if they're being multiplied and I need to get rid of that 3, to get rid of it, I'm going to divide. But whatever I do in one side to math, I do to the other. So I did on the left side of the equal sign and then the right side. 3 divided by 3 is 1, and then the x follows it. And 18 divided by 3 is 6. Okay, and we know 1x is the same as just x. Okay, so we found our x value of our coordinate. So over here at the top right, I'm going to go ahead and write that x was 6. Okay, but now I need to find the y. I need to find the y coordinate. This is where these two equations cross or intersect. Okay, so to find the y value, I need to figure out which equation I want to use. And the answer is it really doesn't matter which equation. I could use the top one, you could use the bottom one. We're going to get the same answer. You are going to plug in the x value, so 6, into one of the equations, so into one of those equations, and you're going to solve for the y value. Okay, so I'm going to do it with the second equation. Okay, so I have 1x minus 3y equals 3. Okay, I know that the x value was 6, so I'm going to plug that in place of the x. Okay, 1 times 6 is 6. And now I need to get the y value by itself. Okay, this 6 has to go away. Okay, and then the minus 3y has to go away as well. Okay, let's get rid of the 6 first. We always get what's standing by itself, the constant. We get rid of that first. It's a positive 6, so to get rid of it, I'm going to subtract 6. But if I do it to one side, I have to do it to the other. Okay, so 6 minus 6, that cancels out to 0. And I can just bring down the negative 3y. Okay, I'm going to let you use a calculator here if you need to. So 3 minus 6 is going to be a negative 3. Okay, and then now I need to get rid of the negative 3. The negative 3 and the y are being multiplied, so to get rid of it, I'm going to divide by a negative 3. Okay, a lot of people say, why don't you divide by a 3? Because 3 is opposite from negative 3. With multiplication and division, you're trying to get rid of exactly what you see. If you're trying to get rid of a negative 3, you have to divide by a negative 3. Otherwise, your y stays negative. Okay, so if I divide by negative 3 on one side, I have to divide by it on the other. Negative 3 divided by 3 is 1, and negative 3 divided by 3 is 1. And we know that 1y is the same as just y. So y equals 1. So for these two equations, I'm going to highlight them. So these equations cross at 6, 1 on the graph. Okay, so the two equations that we were given, we could have graphed them and found out where they cross because these actually happen to be whole numbers, so they cross on a grid. But now we know how to use the elimination to find out where they cross. Okay, let's do another problem. We're going to do 3 total today. Okay, So this time we have 2x plus 3y equals 20 and negative 2x plus y equals 4. Okay, so I want you to solve this using the elimination method, and I can see right away that my x values are going to cancel out. Okay, my x values are going to cancel each other out because 2x and negative 2x are opposites. They're going to equal 0. That's good. It was already set up for us. Okay, so I didn't have to actually do math to get them to cancel. They were already ready to be canceled. Okay, now let's add what else we see. So 3y plus a 1y is 4y, and 20 plus 4 is 24. Okay, I need to get the y by itself. It's being multiplied by a 4. So to get rid of the 4, I divide. But if I do it to one side, I need to do it to the other. Okay, 4 divided by 4 is 1. So I have 1y. 24 divided by 4 is 6. We know that 1y is the same as just y. Okay, so up here in my ordered pair, this time I found the y value first. Okay. Make sure, even though we found y first, it still has to go in the y spot, which is second. Okay. So now let's go find the x. How do I find the x? I choose either one of my equations. It doesn't matter. Okay. I'm going to choose the first one because I don't want to deal with that negative that's in the second one. And now I actually have something that I could plug in because we can't solve an equation for a value if it has two variables, but we know that y is 6. Okay, we know that y is 6. So in this equation, instead of y, I could plug in 6. Okay. 3 times 6 is 18. Okay. And then we need to get rid of both the 2 in front of the x variable, and we need to get rid of the 18. Okay, we get rid of what's not attached to the variable first, so we're going to get rid of the 18. It's a positive 18, so I get rid of it by subtracting 18. If I do that to one side, I have to do it to the other. So the 2x comes down. 18 minus 18 cancels out. Good. That's what we wanted to happen. And 20 minus 18 is 2. Okay. So 2 and x are being multiplied. So to get rid of the 2, I divide because division is the opposite of multiplication. But if I do it to one side, I have to do it to the other. 2 over 2 is 1. The x comes with it. And 2 over 2 is 1. And we know that 1x is the same as just x. So the x value is 1. Okay, so these two equations, this system of equations, so a system of equation is a set of 2 or more equations. So these two equations are going to cross each other at this ordered pair, 1, 6. This is where they cross each other on the graph at 1, 6. Okay, so just to review before we do our last one, you could graph these two equations and you're seeing where they cross. That's the solution. Those two numbers, the x and the y value, will work for either of the equations. Okay, but if they don't cross, or they're not whole numbers where they cross on a grid, But one way that you could solve this system of equations is the elimination method. You're eliminating either the x or the y variable. In this example, we eliminated the x over here. Okay. And then by doing that, we're able to actually then solve for both the x and the y. Okay. I know this is a lot to handle. This is a really hard lesson to do remotely. So if you're even kind of with me, you're in good shape. Okay, let's do the last one. Okay, so in this last one, it says negative 3y minus 4x equals negative 11, and 3y minus 5x equals negative 61. Okay, so this is a system of equation, and we want to find the solution, which is where these two equations will cross. Okay, we're going to use the elimination method. And I can see that I have a negative 3y and a 3y, which cancels out. Okay, they cancel out. And then I can add the rest of the numbers. So a negative 4x plus a negative 5x is negative 9x. Okay, and negative 11 plus negative 61 is negative 72. Okay, I need to get the x by itself. It's being multiplied by a negative 9. So to get rid of it, I need to divide by a negative 9. But if I do that to one side, I have to do it to the other. Negative 9 divided by negative 9 is 1. Negative 72 divided by 9 is positive 8. A negative and a negative with division make a positive. And we know that 1x is the same as x. Okay, so in our coordinate pair, this is where they cross. The x value comes first. Okay, and now to get the y value, I need to go to either equation. It doesn't matter which one. And I need to plug in 8 in place of x. Okay, I'm going to use the first equation. You can use the second one if you are getting the hang of this and you want to just try and make sure we get the same answer. Okay, so in place of x, I can plug in 8. Negative 3y, and then negative 4 times 8 is negative 32. I need the y to be by itself, but right now this negative 3 is still there, and this minus 32 is still there. So we need to get rid of them. I'm going to get rid of what is not touching the y first, so the constant. It's a negative 32. To get rid of it, I do the opposite, which is adding 32. But if I do it to one side, I have to do it to the other. The negative 3y comes down. Negative 32 plus 32 cancels out. And negative 11 plus 32 is a positive 21. Okay. Negative 3 and y are being multiplied, so I need to get rid of a negative 3. So I divide by a negative 3. Okay. It's not the opposite sign this time. So up here, let me go to the laser. Up here, there we go. When it was negative, positive, that's not me doing the opposite sign. I'm doing the opposite math. It was a negative, so I'm adding. Okay. So down here, the reason they're both negative is because I'm trying to get rid of this negative 3. So I have to divide by a -3. If I don't divide by the negative, then the negative sticks with the y, and I don't want that. Okay? So if I divide one side by a -3, I have to divide the other by a -3. -3 divided by -3 is 1, so 1y. And 21 divided by a -3 is a -7. And we know that y equals -7. So I can come up here and plug that in. So in these two equations that I was given, the system of equations that I was given, the solution, or where the two graphs will cross each other, is 8, -7. Okay, so you might be thinking, why would I do all this algebra? Why would I do all this solving? Why can't I just graph them and then find out where they cross? Well, this time I gave you all whole numbers. Next lesson, you're going to have some that are not whole numbers, so you're going to have to figure out where they cross. Okay, and you won't be able to do that on a graph accurately. You'd only be able to do it algebraically. Okay.